Okay, so the topic that we just want to talk about is chemical kinetics, which is like the simplest topic in chemistry. Yeah, that's what we just want to like talk about. Um, so for the people who've been around and have access to a portal, I've explained chemical kinetics and we've looked at several questions actually. I expect you to be able to answer all these questions. So we defined kinetics to be the study of the rates of reactions and reaction mechanisms. Is this what, how did you define it in your classes? So study of rates of reactions and reaction mechanisms. Yes, give us yours.
Chemical kinetics is the study of reaction rates. So something.
Okay, reaction rates and rates of reaction. Okay, good. Okay, that's brief. Anyway, from here we talked about factors that affect the rate of reaction. I think I was looking at the questions, I saw things like collision theory. So we eventually get to talk about everything later on. So let me just go direct to the questions. I believe the concepts are not new to you. If they are, please ask. Yes, there's a hand. Okay, so we'll proceed. We are told for question 1, what is the average rate of decomposition? So decomposition, by now you should know that it's a reaction where you are starting with a single reactant and then it gets to be broken to other components. Now in this case, they've even given us a formula for the rate of the reaction. So I did explain to you that the rate of a reaction can be given in terms of the reactants, can be given in terms of the products. Okay? So if you're going to look at the reactant there, the rate of that reaction or the speed of that reaction can be given as your R representing the rate to be, of course, negative 1 over the stoichiometric coefficient. In this case, it's a 2. Change in the concentration of that reactant over the change in time. This is a formula for determining the rate of the reaction. If we're going to express it in terms of the product, we're going to use, for example, if I look at A, I can say my rate is equal to 1 over 4, and then change in concentration of A divided by the time it took for that concentration to change. These formulas should be at your fingertips. Okay. Now let's try to analyze the question we have at hand. So we've been given that equation. Now they want us to determine the rate as well. Okay. Now what are we told? We are told from 600 seconds to 1200 seconds. What are we told? Use the following data to determine the average rate. So how do you go about it? So I've already given you the formula, right? So what formula are we going to use? Our R is equal to, yes, since we've been given information about our reactant. What will be our formula? I said negative 1 over 2 and then changing the concentration. So we had this minus that. So 1.24, okay, times 10 to the power negative 2 and then minus, sorry, we're supposed to actually find or minus the initial. Let me create some space here. So negative 1 over 4, not 4, 2. Negative 1 over 2. And then for the final concentration, it's 0.93 minus 1.24. Now whatever we're going to find is times 10 to the power negative 2. So I've just put it out because it's common. And then over change in time, the final time was 1200, the initial was a 600. So the formula is negative 1 over 2 change in concentration of our reactant over the change in time. Please, if you've got a question, I can hear some hands. Go on and ask. Yes, is there any question? Have we understood? I'm not able to get anything. Any question?
Yes, I have a question, sir.
Yes, go on.
Are we just picking like one line of numbers, or picking both for finding the average rate of decomposition of A, B?
So I don't know what you mean by one line. I think we've used every data. The time has been used, and then even this part has been used, as you can see. The time is on the bottom.
Yeah, like are we using both numbers, like 600 and
We're trying to find the difference because the assumption here is, of course, it's possible. In fact, not that it's possible, it's a must. The experiment had started at 0 seconds. Now, we're not given information before that. So we're only told between 600 seconds and 1200 seconds, this was a change in concentration. So we're finding the difference, which will eventually give us a 600. Does that make sense? Is that clear? So give feedback, please, so that we move fast. If you're not going to give me feedback, I'm going to slow you down. Pardon? Okay, so I don't know if I'm not clear enough, or I don't know, but I hope you're getting what I'm saying. So what I'm saying is the formula for determining the rate of the average rate is you look at the time. So the time here we are told from 600 seconds to 1200 seconds. So even if we had a lot of data, we're just going to focus on the two that we are given, from 600 to 1200. So now I said the formula is dependent on the coefficients. For the reactants, I've explained this from the start for people who've been around. So it's going to be negative 1 over the stoichiometric coefficient of our reactant, which is a focus because we've said the average rate of decomposition of A2B. So it's negative 1 over 2. Now, on top, we are told, in fact, from the question, we can even see that it's a change in the concentration of A2B over change in time. Okay. The only thing they just didn't give you is this. They want to know if you know. Okay. So what do we do? Now, delta, if you've done calculus, you know what it means, change or a difference, right? So it's going to be negative 1 over 2. Now, subtract this. The final minus the initial. So the final for the concentration was 0.93 times 10 to the power negative 2 minus 1.24 times 10 to the power negative 2 divided by, again, the change in time as well, 1200 minus 600. So you can simplify that beyond that point to find the exact answer. Does that make sense? Please, if you have a calculator, feel free to punch and give us the solution. But just to get a confirmation from somebody who said you answered all these questions, is this the way you went about it, or you answered it in a different way? Is it clear now, the person who asked the question? Okay, so are we good to move to the next question? Okay, so for the next one, we are told iodide ion is oxidized by hypochlorite ion in a basic solution. So what are we told? We are told in 1 molar concentration of sodium hydroxide at 25 degrees Celsius, the iodide ion concentration which is equal to the chloride ion concentration, was as follows. Okay. So what's the question saying? Calculate the average rate of the reaction of iodide during this time interval. Calculate the average rate of the reaction of iodide during this time. So we can see the iodide is given there. Now what can you say about the iodide? The iodide was what? Was the reactant. Okay. So how do you go about it is a question. How do we go about it? So the reason why they are trying to give this statement here, the reason why this statement is given, we are told the iodide ion concentration, which is equal to the chloride ion concentration, is trying to emphasize to say, okay, we can see from the equation these guys are in the ratio of 1 to 1. Okay. So since the concentrations were equal, there's no need of us to determine. We've got nothing to do with stoichiometry here. We're just going to go direct and answer the question from a given data. So therefore, we'll just go again and use the equation. Now in this case, even if we say negative 1 over 1, it's not necessary, but that's what we are supposed to do. It, it adds a difference if we add a 2 or a different number. So negative 1, change in concentration of our iodide divided by the time it took for that change to occur. So basically we're going to do what we did in question 1. We just end up subtracting this by that, and then that by that we divide. Okay. So that will be 0.00201 minus 0.00269 for the top part, divided by the change in time, 8 minus 2. And then don't forget there is a negative 1 outside there. Okay. Any question on how I've answered this one?
Sir, kindly repeat.
So I don't know if you're not, I don't know if I'm fast, or I don't know if you guys are, maybe I'm not clear, I don't know, because these are like the simplest things we're going to talk about under the old story sheet. And I've said this is what we did in question 1. So where have you missed it?
So, like using the same formula that we used for question 1, then we replace.
Yes, then we substitute. So the formula doesn't change for the rate of reaction, and that's why it's very important for you people to learn the concepts before we answer the tutorial sheet. I advise you to watch the videos within the week. But the good part is you've learned in class. So the formula for the rate, like I stated from the start, if you're going to be given a reaction in that form, let me put some coefficients there. If you're going to determine the rate, if a question asks you to determine the rate, whether the average rate or just the rate in general, if you specify the time, the formula for determining the rate in respect to A in this case is negative 1 over 3 change in concentration of A divided by change in time. If I'm going to give it in terms of B, it will be negative 1 over 2. If I'm going to give it in terms of C, it's going to be 1 over 4 change in concentration of C divided by the change in time. So if I'm going to be given data to say, okay, between 0 seconds and 10 seconds, and then I'm told 2 molar concentration, 0.8 molar concentration. What this means is, know that this is your time and that is your concentration. So you just end up substituting in the equation. That's exactly what we've been doing in the past 2 questions. Okay, so somebody has unmuted themselves. I'm getting an echo. Yes, I can see some hands. Just
Hello, sir.
yes, I can get you.
Can you bring back the page that you said?
Matthews, kindly mute your mic, please.
Yeah. Hello.
Yes, yes, I can hear you.
So in the question, the temperature is 75.
Okay, good question.
They just put it there for nothing. We're not using it.
Okay, so 25 degrees Celsius is room temperature. Yeah, there's the formula for the average rate has got nothing to do with temperature.
Yeah, it doesn't. So I just put there to confuse us.
I don't know why you're going to think of a different formula if you know the formula.
No.
I'm sure even other topics previously, you saw that there've been questions where they give you things that you're not going to use. I'm sure you've seen that.
So we can't see anything.
Uh, you all can't see anything?
Yes. I'm just seeing a log for translated gesture.
Okay, can you see now?
No, I can't.
Okay, just leave the meeting and join. You'll be able to see.
Join.
I think everybody, yeah.
Alright.
Can we move to a third question? Please be talking when I'm asking you so that we move fast. Okay. So this is a very common question that you usually get to encounter and chemical kinetics. It's a very common question you get to encounter. So please pay particular attention to this question as we answer it. Iodide ion is oxidized in acidic solution to triodide ion by hydrogen peroxide. So we've been given the equation there. A series of 4 experiments was run at different concentrations and the initial rates of iodide formation were determined. Okay. So what are we told? We are told now to obtain the reaction orders with respect to the reactant we have and then H plus. And the funny part is I've never answered this kind of a question. This is very interesting and I want to see how we can handle it. So we've been given 4 experiments and then we are taught to find the orders in respect to that. So how do we a ratio? I've always said the ratio is just an equation that gives us the rate constant and then we're also given the reactants. So it may be A, usually it's 2, AB. Now in this case it's going to be ABC. Now we are supposed to find the powers of M, N, we can use any letter of your choice anyway, X, Y, Z if you want. We are supposed to find the X, Y, Z. Those are the orders the question is asking about. Okay? So do we have an idea on what the question is asking us to do from what I've explained here? Oh, I don't know if I am very. Okay, so the questions are very simple. Don't stress yourselves. They are very simple. Just take it easy. Okay. There's nothing complicated about these questions. I don't know why they were. I don't know why they were giving you paragraphs, but the questions themselves are simple and straightforward. Okay, is that clear enough? So if you've noticed, if you look at the question itself, it's saying we have to obtain the reaction orders in respect to the reactant. So the lateral is given in terms of the reactants. Okay? So in this case, the reactants we have are 3, and they're the ones the question is asking us about, if you've noticed. So we have H2O2, we have iodide, and then we have the hydrogen, right? So I've said let the powers be x, y, and z. So x, y, and z are representing the reaction orders that they want us to find. So now how do we find them using the given data in the table? That's what we're trying to do. Okay? So let's try to do that. So I'll write for you the equation again. Our R, which is denoting the rate, is equal to K, and then we have H2O2 as one of the reactants, and then we have iodide. And if you can see in the table, actually the information we have is all about the 3 reactants in the equation. So now let our powers be x, y, and z. Any questions right now before we proceed in finding the values of x, y, and z? Are we together? Or we are still doubting? Are we together? Pardon? Okay, so the easiest way would handle in finding the very first one is to look at a case where the other 2 are going to be like constant. So if I try to observe experiment 1 and 2, I can see that the first one is changing, then the other 2 are what? Are constant. Can you see that? Have you made that observation? Okay, so we're going to divide the second one, which I believe has got bigger values, by the first one. Don't forget the initial rate is the rate. So for the second one, it is 2.30 times 10 to the power negative 6 equal to, so I'm now substituting in this equation. K we don't have. The H2O2 is 0.02 raised to the power x. The iodide is 0.01, 0.01, relax. So that is y, and then H plus is 0.0050 z. So we'll divide by the first one. Now for the first one, the rate there was 1.15 times 10 to the power negative 6. We had k, and then we have 0.010 to the power x. So everything else on the other hand was the same. So the idea why we wanted to get the things that are the same is that they can divide and cancel out, right? So that will give us a 1. That will also divide and give us a 1. Now if you're going to divide the k as well, it's also going to cancel out. So what you're going to remain with will be 2.3 by 1.15, which will give you a 2 if you grab your calculator. Now this by that will also give you a 2, maintaining the power of x. So you notice that your x is equal to 1. Mr. Lumuno, please avoid unmuting yourself. You are causing noise in the class. Okay, so is there any question from what I've explained so far? Any question? Are we together?
Yeah, yes, I'm together, sir.
So are we ready to find the other value of... So we found the order in respect to the first one. So the order is 1. Now at this point, if we are lucky, we can find another case where either iodide or hydrogen is also changing, and then the other two may be constant. So I want you to pay particular attention and try to observe where the other two are constant, if there is that case anyway. Can you see any case where the other two may be?
What of experiment 1 and 4?
Okay, that's a very good observation. It took me a lot of time to see that. Okay, so this is 0.010, that's 0.0, so that's constant. That's also constant. Then you can see that the other one was what? Changed. You're unable to see. You can't see anything, or it's not clear.
I can't see anything.
That's a sudden, or you've not been seeing anything from the start, Margaret.
It's breaking. And then it again disappears.
So is that the case with everyone else, or it's just
Same here, sir. It's just the network. I
So your network is very bad in school, because this never used to happen before you got to school. Hmm?
Yeah, maybe it's the network because I can see here. Maybe try to leave and join again.
Okay, anyway, don't worry, I've recorded the class, so but try to join in again and see. So for experiment 1 and 4, we can see that the first reactant was constant, iodide was also constant, and then the other one was the same. Now, if you've observed they are the same, as a student who knows what to do, there's no need of you even to show. So I can go for experiment 4. The rate there was 1.115. So 1.115 times 10 to the power negative 6 equal to K. Now I know this guy was constant, that guy was constant, so even if I'm going to put them, they're going to cancel out. So ultimately remain with the hydrogen, which was 0.00100 raised to the power z divided by 1.15 times 10 to the power negative 6 for the first one, and then K, and then we add 0.00050 for the hydrogen, the power z. So we can clearly see on the left it's basically the same, so it gives us a 1. On the other end it will be a 2. So what's the value of z, if you might guess? It's what? Please be loud.
Sir, what if we introduce logs?
Ah, no, 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 no. I don't want you to use logs.
Maybe 0.
Okay, so the one we have on the other side can be expressed as 2 to the power 0. 2 to the power 0 is a 1. So the bases are the same, therefore z is equal to 0. So what does it mean when z is equal to 0, for the sake of your understanding?
Sir, it means
Come again.
It means that it didn't take part in the reaction.
Is that everybody's view?
Yes. Or it was a catalyst, but it didn't take part in the reaction either because it's here.
Okay.
It has no effect in the reaction.
Okay, so I'll send you talk time for 10 kwacha, Annie, for getting it right. So
Thank you, sir.
there's no way something can be written in the equation for the reaction and then you say it didn't take part in the reaction. Then when why are they putting it there? And if you're going to see the hydrogen we have, it's obviously it's obviously present on the other side most likely, right? Yeah, because the equation is balanced based on it, right? 2 plus 2 gives you the 4 we have on the other side. So you can't say it didn't take part in the reaction. Rather, what you can say is that it doesn't have an effect on the rate of the reaction. Okay. No effect on the rate of the reaction. So because if you look at this equation is what is helping us to determine the rate. Now, if something is going to be raised to the power 0, it means it's going to be cancelled out, so it has got no effect on the rate of the reaction. Does that make sense? So now at this point, you can get any experiments of your choice other than the ones we've gotten so far to find the value of y. If you are lucky, but I've observed there are no two other experiments where x and z are going to be the same and then I is different. Unless otherwise. Well, I can see experiment 1 and 3. Can you see it? I didn't see it before. I didn't see it before. So these two are the same and then iodide is different. So of the same, there the rate was 2.30 times 10 to the power negative 6 equal to k. So for the H2O2, so we can see that this and that were the same, so they will obviously be eliminated. So just go for the iodine, which was 0.020 raised to the power y over the other one was 1.15 is equal to k, and then of course 0.010 to the power y. K will cancel. That will give us a 2. That will give us a 2 to the power y. So y is also a 1. This is very funny. So our rate is equal to k. Our H2O2 denoted to the power x is the power 1. For the y, it's also 1. And then for the hydrogen, it's a 0. So if you're going to give the literal, you can even eliminate the 1 to the power 0 if you want. Okay? No need of you showing the 1. They already understand it's the 1 if you don't show anything. So that's a literal. So the reaction order is in respect to this. To these, it's 1, 1, 0. We've answered the question. The fact that we've answered the one with 3, I don't expect you to fail the one with 2. Come on. So find the rate constant. How do you find the rate constant? Yes, Ruth, go on.
Rate constant. It's just direct. You just have to divide the two rates, both sides, then you leave k alone. You pick any experiment. Most cases we get experiment 1. Then we just replace the values since we have everything.
Okay, you can get any experiment of your choice. So you get the first one. The rate there was 1.115. K is what we're trying to find, so we don't know the value of K. So divide by these other two on the other side. So for the H2O2 we add 0.010 to the power 1 in this case, and then for the iodide it was 0.010 as well, to the power 1. That's going to give you the value of K. Now for the units, I gave you a tip. I said it's just m 1 minus n and then k to the power not k, second negative, where n is the overall reaction order. In this case, what's the overall reaction order if you're going to add all the orders we found in respect to the reactants?
Say two.
It's 2. So 2. So you're going to put the 2 there, it will be m negative 1 second negative. So those are the units for the k. There are questions where they ask you to find the units of the k. The other way you can find it is by substituting. You know that this is molar concentration, molar concentration. The rate is molar per second. So if you're going to divide by molar squared, you end up with 1 over molar dot second, which is eventually equal to that. So what's the value that you're getting after dividing? Remember what we're multiplying first of all is we're multiplying. In such cases, I advise first of all dealing with the denominator. We have 0.010 times 0.010 to the power 1. Whatever you get, divide that into 1.15 times 10 to the power. I can't have a power here. The power negative 6. Anyway, you should be able to get the answer. I'm not having a calculator right now, unfortunately, so I'm not able to. Okay, have we gotten the idea? That's what's important at this point. Have we gotten how to go about it? Okay.